हाय एवरीवन। आज हम एक गेट टी ए 2025 का क्वेश्चन सॉल्व करने वाले हैं इस वीडियो में। एंड ये क्वेश्चन बेसिकली प्रोबेबिलिटी एंड स्टैटिस्टिक्स सब्जेक्ट से था। एंड रिलेटिवली काफ़ी मतलब नॉर्मल सा ही क्वेश्चन था, जस्ट गिवन इन्फॉर्मेशन दे रखी है एंड वी डोंट हैव टू थिंक मच। But yeah, like the way it was written in the examination, even I felt like while I also prepared for a GATE TA 2025 and I also appeared this year. So yeah, actually I did this question wrong, and that was because of just that was a very silly mistake. I'll tell you more once we are done with the question solution. So let's first read the question and maybe just like try to solve it. Okay, so here we are given that x is something of the form az plus b, and z is a standard normal random variable, and a comma b are two unknown constants. So in this question, since we are given the unknown constants and the option seems that we are supposed to find these unknown constants. So they have given some information regarding what are the expectation of x and some combination of z. So these we are given some expectation values for the random variables, and we are supposed to use these given information to find the values of a and b. Also we are given that z is a standard normal random variable. So we know that what is the mean and standard deviation for a standard normal random variable. It is 0 comma 1. So that's why we know what is the expectation of z. And so basically expectation of z is 0. And we can also find, since we know that the variance of z is 1, and we know that the formula of variance is like expectation of z square minus expectation of z ka whole square. So since this term is 0, we can say that we know that expectation of z square is 1. So we have some information regarding z, uh, and we are given some other expectation values as well. So to begin with, like we know that x is of the form az plus b, so we can just substitute it using this expectation of x equals to 1. We can write it as, and we know that expectation is a linear operator. So like there's a derivation for that as well, but I'm skipping that as of now because I assume that this is a very basic result. We can prove it, but yeah, that's actually very basic. Like you can just use the integration formula, like just to quickly demonstrate it. So if we are supposed to find the expectation of az plus b, then we have some az plus b, which is the variable, and this is some pdf of in the form pdf of the z. So here we can see that we can basically integrate in the integration also, we can linearly separate it. So this will turn out to be, and plus this term which is b of fz dz. Since we know the, fz is a pdf, that's why we know this integration over the domain of z is going to be 1. So we are just left out with, and we know that this is the formula of expectation of z. So this will be a times expectation of z plus b, and this is 1. So that this is just a basic idea of how we can derive this, but that's one of the very basic results, and we should remember it for the future purpose. So okay, so we know that expectation of z is 0, that's why we can say that this term is 0. So this this whole term expectation of x is b, and we are also given in the question that this term is 1. So we, like, finding the value of b was very simple task in this question. Like even when I solved this question in the exam, I was able to find b very quick, like exactly how I did right now. But The tricky part for me actually was finding the value of a, because I remember in exam I was getting a square equals to 2, something like that. Uh, a square equals to 4. I think I got value of a square equals to 4 after solving both these two equations. But since we have minus 2 and 2 as well, along with b equals to 1, or I think there was something, or I think I was just missing whatever, like I think I did not mention it here. I did not checked it carefully, but if I would have gotten this b equals to 1, I could have directly marked this as the answer. But okay, I did some silly mistake in exam, and that's why I got a negative marking for this particular question. So that's why I wanted to solve this again. And yeah, so moving on, now we have p equals to 1. Now one thing is that we can proceed with solving this equation and also this equation. And one thing is that let's look both of these solve both these equations simultaneously, or just first let's try to solve one equation at a time. So right now I'm just focusing on this one, x minus expectation of whole square. The expectation of this is given as 4. So since we know that expectation of x is 1, due to this first equation, we can write it as this, right? And this is basically, we can just open this square, so this will be that's a very simple basic identity, and we can write it as expectation of x square minus 2 times of expectation of x plus 1. We know that the expectation of any constant is the constant itself, and we can also see it from here, like expectation of b, if we go, we can just pull it out outside the integration, because it's a constant and it's not a function of z. So when we integrate f of z over the entire domain of z, that will be 1, so we will be only left with b. So this is the idea. And this, and we know that expectation of x is 1, so we can just substitute it to minus 2 plus 1, and like this gives us that expectation of x square is 5 basically. Okay, and what we are supposed to find is the value of a. Okay, and the other equation is expectation of x minus, here also I'm substituting this as 1, and for z I'm just keeping it as z as of now. And what we can do is we can further solve this like this, and then we can write it as expectation of, due to the linearity of expectation operator, we know that this is 0 since it's a standard normal random variable. We saw it here, and then so we are left with expectation of x z equals to minus 2. And we know that x is something of the form a z plus b, so let's substitute that as well. And now we have we can just open this, and this will be a times expectation of z square plus b times expectation of z. This term is again 0, so we are left with a times expectation of z square equals to minus 2. We know we already calculated the expectation of z square here, and that was 1. So we got a as minus 2. So yeah, we didn't actually had to, like, even if we would not have used this particular equation, the third one, we would have still got the answer by using just the first two expectation. So yeah, the question was actually simple, but I still did a silly mistake in marking the answer, because what happened was when I solved for the value of b, I was able to get it easily, but when I was solving for a, I think I was confused and I got something like a square equals to 4, as far as I remember. And then I was confused by the options for some reason, maybe because I was panicking. And then I marked, I could not find it then, but I came back again to this question later on. And when I came, I was able to find this a equals to -2. But at that particular point, I forgot that I solved b as 1, and instead I marked this option, like C option. I marked this particular option in the exam, whereas A was the correct option. Like we can see A equals to -2 and B equals to 1. So yeah, in exam we tend to panic a lot, and that's why we might make such silly mistakes. So I'll hope that you guys can see what kind of mistakes we can avoid. And whenever you mark a question, just maybe do a quick check, or maybe try to solve the question again. Like leave some sort of space. What happened with me, I was solving each and every question in that like from the beginning only, in that beginning of the rough sheet only. And when I came back to this question, I almost forgot where I solved it previously. So what I would suggest is that leave some space for solving that question, so that you remember that what is the solution that you have already got before. Like if you have half solved it, what was the answers that you have got. So yeah, that was all about this video. I'll try to make some other videos as well based on these questions, in case you guys think that it was helpful for you. So let me know in case it helps you, and like, share it if you think it might help someone else as well. So that's all for this video. Thank you.